Okay, a piece of wire 100 centimeters in length is bent into shape and all corners are right angle triangles, and the measurements are in centimeters. So part A, find the expression for the perimeter. So the perimeter would be when we add up all the sides. So we'd have that side, this side, we'd add all of these up. Now we can't see what the length down here is, but if you have a look, we break that down, that would be a 2x there, that's the length of x, and that's a 2x. So if I go to A to find the formula for the perimeter, we would be adding up all the x's, all the terms, x plus y plus along the bottom here, that's 5x plus another 5x plus the y. So I've added them all up, and if we group all like terms, we end up with 12x plus 2y as the perimeter. Now, we know the perimeter is 100, so I could write 100 equals 12x plus 2y. So there's an expression. Okay, in part B, it says we'll find y in terms of x. So I can rearrange this to have it y equals. So I could bring the 100, bring the 12x on the other side, equals 2y, and then I'm going to bring the 2, so I'd have 100 divided by 2 minus 12x divided by 2 equals y. So I get this formula, y equals 50 minus 6x. So I now got a formula for y. In C, find the area enclosed in terms of x. So if we go and look at this, the area, if I drew a big box like that, so if I was finding the area of that big box, we would do length times width. So we worked out that this was 5x and this would be 5y. So if you were doing the area for that, it would be 5x minus y. But it would be, area would 5x times y, sorry. Okay, but we don't have that error. We actually have this little bit that's not there. So if I was to minus that out, if I cut that bit out, so if I minus the area of that bit, which would be x times x, so x times x, if I minus that, I end up with the area that I wanted. So I end up with this shape here. Alright, so I'm going to work with this formula. So I've got 5xy minus an xx is x squared. Now we want to get it in terms of x. So I'm going to use this y instead of y over here. So I end up with area equals 5x times y, but that is 50 minus 6x minus x squared. And then we're just going to expand that out. So that'll be area equals 250x minus 30x squared minus x squared. Group like terms, we get 250x minus 31x squared. So there's the formula for area. Okay, because they want to describe the situation in function notation, we do want to try and find a reasonable domain, or the implied domain for this one. So let's do a rough sketch of what's happening here with this. So it's a quadratic because it's a squared term is the highest. So if I square, so we've got this quadratic here, 250x minus 31 squared. So this would be area along here, and this is x. So when we sketch a quadratic, we have to factorize to get the x-intercepts. Okay, so if I do that, x is common, so I'd get 250 minus 31x. Okay, so we've got area. Now, so if we were drawing this area and we were finding the x-intercepts, we'll let area equal 0. So if we let it equal 0, then we let each factor equal 0. So we get x equals 0 and x equals 250 divided by 31 is the other x-intercept. So if we're sketching this, it looks something like that. Now we're never going to have a negative area, so we're not going to go down there. So we know that's 0, 0, and we've got the other one is 250 over 31, 0. So we can see now our domain is really restricted to 0 up to 250 to 31. Now I'm actually going to change my brackets here, to curved ones, because remember we've said it in class 2, we can never have a 0 area, so really we should have 0, a curved bracket, because we should never have 0. We can have all the numbers leading up to it, and same with the 250 minus 1. So if we went to now write that out in set notation, we've got the domain to write it out as. So you know how we see that set, so we might say A is a function with this is our domain, anything between there set onto the real field, and then we'll put the formula for area of x equals 250x minus 31x squared. Okay, so there's our thing. Alright, in the last question when it says find the maximum area of the shape, well, maximum area is going to occur at the turning point. Alright, so we're going to get the turning point of our quadratic. So, a turning point, we can use x at the turning point is equal to negative b over 2a. So in this case it's negative 250 over 2 times negative 31. So we end up with a positive, so we get positive 250 over 62. That's x at the turning point. Alright, so probably when we got to this stage, we are going to probably be using our calculator. So on the next page, I'm going to show you what to do. Okay, as I said before, this is probably an application question, so you most likely would have your calculator, and looking at the numbers, they're big numbers, so you would have your calculator. So now that we've got the formula for area, so we had area was equal to 250x minus 31x squared. Sorry, I've missed the squared there. It's probably best to define it in your calculator. So this is a way we can get exact answers, which is what we want in methods. So to get the define, you press menu, actions, and define. And then you type what I've typed there. So define will come up and you type f of x in brackets equals that and press enter, and you should get the done. Okay, now that we've defined it, we want to find the maximum, because we know this was a quadratic and so it's turning, and we know that's where maximum area is. So we want to find the maximum. So we want to get this function here. Now to get that up, I've showed you, you press menu, calculus, and then function maximum, and that will bring up the f of f max. Now what you have to type in is the f brackets x comma x. Now it's told you that there's the answer. You get 125 over 31. That's x at the turning point. Alright, so now you know that's x at the maximum. Because you've already defined the function, you can find y just by putting that, you type f and you put what the x value is and press enter, and here is, and that's a good answer because that's the maximum area in an exact form because it's in fraction. If you trace a graph on a graph page, you won't get a fraction. So maximum area for this scenario is is the 15625 over 31, and it was all centimetres, so I'll say centimetres squared. Alright, so that's that one.